Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, this is the next video which I am recording today related to electric and hybrid vehicles. Earlier I recorded for IC engines, but nowadays the things are changing and we are moving towards the electric vehicles. If not electric, then the hybrid vehicles definitely we must use. Reason, it is well known to everyone, but why we have to do so? This is what the answer. Why we need electric and hybrid vehicles? Because the over dependence on petrol and diesel, rising petrol and diesel prices, very clear, nothing to make, pollution and the resultant global warming known to us, noise in conventional vehicles, need for alternate power source, need for eco-friendly vehicles, electric vehicles, hybrid electric vehicle is the answer for all these things. So, why do we go for electric and hybrid vehicles? These are the reasons why we should go. That is why it is included in the syllabus of engineering. Okay, why do we go for this? Okay, so this is the answer, need for electrical and hybrid vehicles. Now, what do we mean by this? So, an electrical vehicle is an automobile that is propelled by one or more electric motors using electrical energy stored in energy storage device. Second, the primary components. What are the components of any electric vehicles? Motor, controller, power source and transmission. Okay. So, this is what the meaning of electrical vehicle. It means we are going to use the electrical energy, and through that energy a electric motor will be governed, and that will govern the rotation of the wheel, transmission of the power through the electric means. So, this is, so I am not going in much detail of electric vehicles or hybrid vehicles, but as per our syllabus, what are the things? So, very elementary things we are going to discuss here. So, the first is why do we need, second what do we mean by electric vehicles. This is the block diagram. Obviously, if we are using battery, then there must be a charger, power converter, then for power converter there must be electric motor, then electric motor is controlling the transmission or driven shaft, then the wheel. So, this is the block diagram, okay, how the power is transferring from battery to wheels. This we can see in terms of this also, okay, what are the components. So, motor, generally we use brushless DC motor which is able to self start, controller to control the brushless DC motor for increasing the efficiency and reliability and battery life. This is what the purpose of controller there. Charger to connect batteries with electric source. Okay. Contactors, on off switch powering up the drive circuit when we turn the key. So, when we turn the key, so there is a contact between two components. So, on off switch as we do in our electric switches. So, this is what like a, so it is a contactor, it connects what, powering up the drive circuit when we turn the key. Battery, rechargeable batteries generally used. So, I am not going in the specifications of these because this is what related to the design of electric and hybrid vehicle. Here we are introducing only the components, here we are introducing only the term, what is electric vehicle, why do we need and what are the components. So, okay. So, which type of motor, what will be the power of that, how much RPM, that I am not going in that much detail, I am only telling that these are the components. Advantages of electric vehicles, obviously need and advantages both are meeting. So, no gas required as an IC engine, no emission, cost effective, okay, low maintenance, payback period is very soon, very early, low noise, because in IC engine there are number of components, but whereas in motor there are less number of components. So, noise level will be lesser. Disadvantages of electric vehicles, high initial cost. until unless we are going for the mass production, its cost will remain high. Short driving range, yeah, this is the because the battery requires more and more electrical energy and there is a capacity of battery also. Second thing, we do not have the recharging station at nearby places nowadays, at least in present scenario we do not have. So, refilling or recharging is an issue. Recharging takes much longer time than refueling. Yes, this is also one of the problem with electric vehicle. So, as the scope is there, so obviously the challenges are also there. Battery pack takes space and weight of the vehicle increases. Yes, this is also one of the drawback or disadvantage of electrical vehicle, but we have to come at some trade off. We have to come with some solution, some optimized solution, so that we can go with some eco friendly and good solution. So, this is what the electrical vehicle. So, now if electrical vehicle is not fulfilling the requirement and IC engine is having certain issues, then what is the solution? The solution is hybridization. The solution is hybridization. So, the concept of hybridization means multiple sources of power. Obviously, so here we are not talking about multiple sources, here we are talking about two sources, one is the electric source, another one is IC engine, ICE. So, concept of hybridization between these two sources, making IC engine work in most effective range, sizing of motor. So, motor size is a matter, battery life is a matter, battery recharging is a matter. So, that we can reduce with the hybridization. So, sizing of motor and IC engine lower compared to conventional vehicles or electrical vehicles. So, this is how the concept of hybridization comes in picture. Now, which type of hybridization? How much hybridization? How much do we require? So, on the basis of degree of hybridization, we can classify hybridization in three categories: mild, then soft. So, mild means they feature idle stop function, regenerative braking is there, but are not capable of using the electric motor to propel the vehicle. This is what we mean by mild hybridization. If I go with the medium hybridization, then obviously most of these type of hybridization are not capable of using the electric motor alone to propel the vehicle. So, not only the electric motor is used to propel the vehicle, but along with IC engine it can be used. And if I am going with the full hybridization, then the most of this type of hybridization prefers what? Are capable of using the electric motor alone to propel the vehicle. So, mild, medium and full. In mild, we are not using the electric motor to propel the vehicle, whereas in medium, not only the motor, but the IC engine also, but in full hybridization when I am talking about, then electric motor also assists the engine. This is what the meaning of full hybridization. Now, so if we understand the concept of hybridization, then we must understand these terms also. Okay, what do we mean by hybrid vehicle? So, that term hybrid vehicles in general refer to the vehicles with 2 or 3 different type of sources delivering power to the wheels for propulsion. Okay, clear? 2 or more sources, if combined together, then it is hybridization. The most common hybrid vehicles have an IC engine and one or more electric machine, mainly motor, for vehicle propulsion. The IC engine can be used to generate electric energy on board. When the vehicle is running, then the electric energy can be generated, can be produced through the running of the engine, which can be used for charging the batteries and to propel the vehicle also. So, this is what the general concept behind the hybrid vehicles. Now, how can we classify? Okay, so, based on the energy, how the energy is flowing. Mechanical power transmission path, MPTP, the first type, okay, which we generally use. Electrical power transmission path, this is what the meaning of electric vehicle. Then we are coming to the combination, hybridization. Hybridization of what? Mechanical power and electric power. So, combination of MPTP and EPTP. Second type of hybridization when we do, that it means how these powers are hybridized, how these are clubbed. It can be a series combination, it can be a parallel, and it can be a mix of both. So, what are the advantages and disadvantages of all these, that we will be discussing in next slide. So, another classification based on degree of hybridization. So, mild, medium and full, we can also say mild, power and energy. Then another classification, charge depleting and charge sustaining. So, these can be various ways of classifying the hybrid vehicles. Here we are coming to the first one, okay, how the power is moving from source to wheels. So, mechanical power transmission path. Okay. So, the primary powertrain components in a conventional IC engine vehicles are engine, okay, and transmission. The energy flow in vehicle starts from the source of energy, and here the source of energy is what? Internal combustion engine, and it ends at wheels with the delivery of propulsion power known as power transmission. So, the very clear, the whole system is completely mechanical. The fuel which we are burning in IC engine, that is causing or that is producing the power, and that power with some transmission mechanism is transmitted up to the wheel. So, this is what the mechanical power transmission. Okay. This is what the mechanical power transmission path, here complete mechanical. Now, I am coming to the electrical power transmission path. Here the source is changed. Now, the source, instead of IC engine, we are having electric motor or some electric machine. Okay. So, energy storage, it is from battery, and from battery that energy is extracted by that electric motor or machine or the some drive, and that is coupled to some transmission system, and it is transmitted up to the wheel. So, in electric vehicles, power transmission is almost electrical except for coupling device. So, here the whole thing is electrical other than the transmission system. So, this is what the electric power transmission path. Now, the combination of both MPTP and EPTP. The propulsion power is transmitted to the wheels through either MPTP or EPTP or combination of both. The MPTP is associated with an IC engine, means mechanical power which is coming from IC engine and transmission, whereas EPTP consists of energy storage. So, this is what the combination means, electric energy is stored. So, this is what the electrical part, and the mechanical part is the transmission. Okay. So, this is what the combination of MPTP and EPTP. So, here we can see the diagram of hybrid vehicle. Okay. So, internal combustion engine, from internal combustion engine a power by the burning of fuel is produced. That power can be directly transmitted to the wheels, or that power which is generated in IC engine that can used for charging the electrical energy, charging the batteries. Okay. So, electric generator and electric energy storage is there, and now that with the use of some electric motor or electrical machine or drive, it can be transmitted up to the wheels. So, it is a combination of MPTP, EPTP, and the power is generated from where? Power is generated by combustion of fuel which is in the IC engine, Now, the second type of classification was based on the architecture of the hybridization, okay, how it is. So, first one was the series hybrid electric vehicle, So, a series hybrid is one in which only one energy converter can provide propulsion power. Only electric motor provides all propulsion power to the wheel. A downsized IC engine drives a generator which supplements batteries and can charge them when it falls below the certain charge level. The drawback is size of traction motor. So, now I am coming to the diagram, okay, block diagram. From here it will be more clear. Here is an engine and electric generator both are connected in series. So, here the complete power by the burning of fuel which is generated here, it is transmitted to the generator, it is stored in battery, and that battery drives the motor, and motor transmits this power to the wheels. So, this is the series. Here the engine means the mechanical system and the electrical system both are in series. So, this is what the, so this is the series combination. So, what are this? Only electric motor provides all propulsion. So, obviously, when engine and motor both are connected in series. So, engine is not directly giving power to the transmission system, engine is giving power to the motor. Okay. Then a downsized IC engine drives a generator which supplements batteries and can charge them, but the engine can be of a small size. Okay. So, this is what the series, here engine and motor both are in series. Advantages are what? Flexibility of location of engine generator, simplicity of drivetrain, suitable for short trips with stop and go traffic. Disadvantages: it needs IC engine, generator and motor. Motor must be designed for maximum sustained power that vehicle require. All drivetrain components need to be sized for maximum power for long distance high speed. Okay. So, this is what the series combination. If I go with the parallel hybrid vehicle, so what does it mean? A parallel hybrid is one in which more than one energy conversion device can deliver propulsion power. It means we are having two sources. Okay. The IC engine and electric motor are configured in parallel. Yes. So, this is what the meaning of parallel combination of or parallel hybridization. So, here I come to the diagram. Here is an engine. Okay. This engine is supplying power to the transmission system, then for the wheels, whereas it is in parallel combination of electric system also. So, here is a battery which controls the motor, which supplies power to the motor, and that motor is also connected with the transmission system and it supplies power to the wheel. So, it means it is a parallel, there is a redundancy in system, engine is also, IC engine is also there and battery is also supplying power here. Okay. So, this is what the meaning of, this is what written also, the IC engine and electric motor are configured in parallel with a mechanical coupling. Advantages: it needs only IC engine and motor. Okay. A smaller engine and motor can be used to get same performance, but okay, but the problem is what? Control complexity increases. How to control the power, how to control the sources, how to change over, how to switch over. Okay. So, to control complexity increases since power flow has to be regulated and blended from two parallel sources. The power blending from IC engine and motor needs a complex mechanical device to control it. So, this is what the disadvantage of parallel system. Now, here comes the combination of both. Some advantages of series system, some advantages of parallel system we can get. So, it combines the benefits of series and parallel architecture. The power split device divides the output from the engine into mechanical and electrical transmission path. Even IC engine is also used to charge the battery. So, we are getting the advantage of both. So, now come to the block diagram here. Here we are having an engine, here is a power split. So, from engine we are splitting the power in two ways. One is going to the generator and one is directly going to the transmission system. So, some power is used for driving the wheel, which is developed in the engine, and some power is going from generator to inverter and inverter to battery. So, battery is also getting charged continuously. So, this is what the series parallel combination. Okay, series parallel combination. In series we are charging the battery with the help of engine, but in parallel engine is driving the wheel separately and battery is driving the wheel separately. We are controlling by some changeover mechanism, but here engine is charging the battery itself and transmitting the power to the wheels also, and battery is also transmitting the power to the what? Wheels. So, this is what the combination of series and parallel architecture. Now, here comes the torque characteristics. So, first I would like to go with the details. The torque characteristic of a motor is shown along with the torque characteristic of IC engine. Yes, here are the, this is for the motor torque characteristic curve, this is for the IC engine torque characteristic curve. Okay. What is written over here? For electric motor, a high torque is available at starting. Okay. So, we can see In motor, in case of motor, the high torque is available at the beginning itself, whereas in IC engine the high torque is available somewhere in between. Okay. The peak of rated power from a motor is obtained at base speed. Okay. The peak or rated power from a motor is obtained at base speed. So, here this is the base speed. So, here we can get the maximum motor power. When motor characteristics enter the constant power region from constant torque region, once voltage limit of power supply is reached, the motor rated speed is at the end of constant power region. The IC engine peak power and torque occur at the same speed. So, what is the advantage of motor here? We are getting the maximum power in the beginning itself. So, this is what we can get from the torque characteristic curve of the motor. So, we can compare the torque characteristics of motor and IC engine both. Now, we can come to the challenges. What are the challenges with the hybrid vehicles? Time of battery changing is long, battery are heavy, batteries are expensive, low performance in hot or cold temperature also may damage the battery, very sensitive to overcharge, undercharge. So, contain toxic heavy metals, disposal is issue. So, as it is a solution, so definitely some challenges are also with the so it is the scope where we can work. Here we can work and we can identify some better solutions which are eco-friendly also, sustainable also. So, now, but along with some challenges, we do have some advantages: environment friendly, financial benefit, less dependency on fossil fuels, regenerative braking system, built from lighter material. So, disadvantages of hybrid: less power, okay, sometimes expensive, yes, initially these are expensive, poor handling because complexity is more, maintenance cost, yes, because of two type of power transmission system there is a heavy maintenance is there.